Hi everyone, and thank you for being here. I'm going to present today one of the products that we have worked in the past year called Road Surface Inspector, which we use it's in production now in Denmark for road condition assessment. And I'm going to say a bit later what that actually is, and we are using a lot of deep learning and cool things in the background. As I said, my name is Bogdan. I'm coming from Denmark, from a company called IT34, where we do a lot of GIS development in all spectrum of products from CAD to GIS. Why have we chose to build a product for road surface inspection? Historically, in order to assess the condition of the road, what that means is finding out if there are potholes, if there are cracks or other damages on the road. You would have to go outside. Some of our customers used to drive around and write down, I have a problem, something needs to be done, and so on. There are options where you take an image and then you have a location next to it, and so on. So we are trying to automate this workflow as much as possible. So everything becomes a bit faster. All the data is managed in one single place, so you can see how the condition of the road is, you can plan the work, and so on. And also important to be able to drive around and find out what the condition of the road is multiple times a year, as it's more time efficient. Our system is now it's composed of three main components. Road Surface Inspector app, which is a tool for data collection. It's basically taking videos of the road. Then we have the Road Surface Inspector, which is a web-based solution where all the data that's coming from the phone and from the deep learning processing can be seen and visualized, some heat maps, and I'm going to show a bit later. Now, all the damages that our deep learning system found on the road, they are just some damages, some information. You need to have them in a place centralized. You see, these are the damages which we consider being tasks to be solved. That's why we have built an integration with one of our other products called Task Management, where you can actually see everything. See the road, have here the task, they can be sent to the specific teams. We have a team that handles with potholes, we have another team that handles with and repairs cracks. Next, I'm going to go a bit into detail on every single component of the system. As I said, Road Surface app, it's a very simple app. We developed it only for iOS, and that's due to Android has a lot of camera models, so it's a bit hard to have good results all the time. There are many camera models, while iOS, they have this amount of phones, and it's easier for us to say to our customers, we would like you to drive with an iPhone, this version or this version. And the quality is a bit better from our test. It's a very simple app. You log in, and then you choose for whom would you like to work. We have a lot of municipalities in Denmark, so if you work with different municipalities, you just choose the customer for which you are doing the work. And then you are starting to film. You put the phone in the car, in a normal holder, and then it films the road. In the next version that's coming up next week, we're also going to have a map, so you can see your location, you can see where you have driven, and you can also see your planned routes. So if you have to drive in a neighborhood, you do it in 2 days, and then you can see the data from the previous day, so you know where to drive. But it's as simple as that. You just do your recordings. Data is being uploaded every 5 seconds as 5 seconds videos. We are recording a GPS position every second. That means that we get back 5 seconds of video and 5 GPS positions that will later be processed. Now we have all this data that we capture, we process it, but we also need to see what the results are in a nice way. That's why we build what we call a Road Surface Inspector Viewer, where you can look at the data and can manage all the routes that you have driven. We call a route from when you start the phone until you stop the phone, and you can have multiple routes per day and so on. Here I made some test data in Denmark. You can see on the left side some of the cold routes that I drove. On the right side, they are just represented with a black color. We also have a status. That means what is the processing status of the data. While you are driving, the status is driving. When you stop the recording, the data is already on our servers. We are starting the processing, then you get the processing as a status, and when it's ready, you can access the actual route and see how the roads are where you have driven. How the results look. At the moment, we have two types of heat maps. One is a heat map in every place where a photo was taken. We just count the number of damages that can be seen from that point. And it's a very simple way of seeing how many damages of any kind I have from this point of view. And this is the sort of heat map that you can see. It's actually just a count on every single point. In the background, you can see some green lines, and a bit in the corner is a yellow line. We are doing some computation. They're trying to, just from image and angle and so on, trying to find out how large the damages are. And something that's just specific for Denmark, we have some tables that describe exactly how much a damage should count when you consider the whole road, and which classes are more important than other classes. And in that way, we can build these nicer colored maps with the state of the road in a municipality or a piece of land. And of course, we can just add any kind of layers and data and so on. If you have driven, for example, for a whole week and you are interested to see all the potholes in the area, you can easily make a filtering based on the type of the damage that you want and the time frame that you want. And you get something like this. You get all the damages in a list with the representation on the map where they were found, and also the image, so you can see how the damage actually looks. From here, in the top corner there, the last button, you can click and get a CSV report that has street name, damage type, when was recorded, who has recorded, so all this information available. There's the button on the left corner where it says create tasks. I'm going to present it a bit later, how that works, but every single detection, as we call it, or pothole that has been detected can be considered as a unit of work that needs to be solved. So that is, from here, is being sent to our task management system, and it's the integration I'm going to present in a bit. If you would like, for example, I just go a bit back here, to inspect an actual route. I have driven here on this street, and I would like to go and see the images and see actually the detections for that area. Then you can just, under action there, you can just go into route, and it's called the route inspection mode, and you see something like this. On the right side, you have all the points, which is actually the images that we were taking from the video, and also the heat map on top. And then for each image, you have the actual image, and then you can see all the detections with the classes. Technically, for this part, we are using, on the right side, it's Mapbox. In the middle, it's open layers. And the image is considered a raster from 0,0 coordinate. And all the bounding boxes that are coming from our model are saved in the PostGIS database as a geometry in local coordinate system close to 0,0. That means that we can draw them on the map, we can modify the polygons, and we can put labels and so on. So we made a viewer based on open layers. You can have buttons, and so on. The damages that you can see in the image are also visible on the left side. Now here the user has the possibility to inspect, see, are these okay? Maybe the model made some mistakes, we are improving the model as we speak. The user has the possibility to delete some of the damages. In the moment you delete the damage, of course, the heat map will also reflect that, and the color will change, the count will change. More importantly, the user has the possibility to draw another bounding box with maybe a pothole was missed, so you can just draw another bounding box, you can create a task and so on. What we do with the bounding boxes that the user have driven manually, we are saving them in the database as damages or annotations that have not been in the training until now. And then we do some sort of continuous training, continuous deployment if you want. So then it's a sort of crowdsourcing annotation as we keep in the database everything that someone have chosen to annotate. Go here. Do you have a button there up? No, it's inactive create task, the blue one. When you create task, it's just a little formula. You say, I have this annotation. I'd like to create a task so someone can do something with it. You can choose a priority, and then you can either leave the same class. The pothole maybe was identified wrongly. It should be a crack instead. Then you can also choose change the category, and then create a task in our task management system. As soon as you have created a task or sent it to our task management system, the color of the bounding box changes. You can no longer edit it because it's already sent to be solved. As you can see here in the image. And then a quick view of the task management system is something we have developed ourselves. It's initially built only for GIS tasks. All our municipalities are using it for a lot of tasks. We have apps that can send tasks based on your location, and then the municipalities are handling the tasks and so on. All the employees have a user, they log in, they receive their task, there's a possibility, I can show you here. That's how it looks. It's location on the map. You have a task list on the right side up, and then the details of the task. You can have description, you can have images, comments back and forth with the people in the field, status change, integration with other systems. So it's a complete task management system that we use. And it's not only for JS, it can also be used for IT support, tickets, or anything like that. So tasks from Road Surface Inspector are coming in this system, and they can be sent further to be solved. We work, a task has a status when it comes to the system. It's registered. When we send it to task management system, it's becoming assigned to someone. When that someone has finished the task, the status changes to completed. As soon as status changes to completed to a task that came from Road Surface Inspector, the status also changes in this system. So that's becoming green. That means that have been solved. So it's a full integration with a task management system where you can see all the damage that you have, and you can plan accordingly when and who and. A bit of system architecture. For the web part, we are using Vue.js, Mapbox, and OpenLayers for the map part. Backend, for the map part, at the moment we are using Node.js. We are planning to switch to .NET. And then for data storage, it's Postgres, PostGIS, and all the data is on-premise. As most of our customers, they don't trust the cloud. So we keep all our data with us. If someone wants to have their data available in their own GIS system, then we use GeoServer to publish it as a VMS or VFS service. Road Surface Inspector app has its own backend and sends data through something called GeoProcessor, which is our internal job queuing system, which have developed internally because we have so much processing to do every single day. And the data is being sent to servers on premise and the Postgres. GeoProcessor, I don't have a lot of slides about it, but it's an end-to-end system for publishing pipelines which are made out of jobs in a specific order, parallelization, choosing on which machine something should go, closing a node, giving more resources or more jobs to run on a node. Or in here we have, when data comes from the app, we have 3 modules. Video processing, which takes the video and works with the Postgres database, takes images out of the videos and does some interpolation and so on. So we have all the images based on where a person have driven. Then we have object detection modules. There are multiple models. We use YOLO 7, and most of the data is something we have annotated ourselves, many thousands, tens of thousands of images. And then we have different modules, some for potholes, some for cracks, and some for manholes, and so on. And in this image, we also have a module that recognizes traffic signs detection. We are working now on detecting damages on traffic signs in general. It's quite a hard problem. Future development. The product is under very active development at the moment. We are planning to add another class that's called registration. At the moment, we are finding damages, what we call damages. But imagine that you have a city and then you want to map all the manholes. Could you just drive around, find all the manholes in the images, and put them directly in the database? So that's registration. All the light poles, for example, drive around, detect them in the image, pinpoint them on the ground, and then you have all the data instead going with the GPS and so on. New classes that we are working on: damages on traffic signs, damages on actual manholes, and damage on street markings. All a bit hard problems, but we are trying to gather a lot of data now and do annotations and so on. Clearance for vehicles. When a tree in the spring or so, it's a bit down and cars cannot pass, we are trying to detect that. Yes. If you have any questions, you're more than welcome to write me, or we can have a coffee afterwards.